The main parameters tested in bridge static load tests are deflection and strain. In this lesson, we'll learn about static load test strain gauge attachment. Behind me is the campus workshop bridge. The second span of the bridge is a simply supported T-beam structure. A detection platform is installed under the bridge. Can meet the requirements for inspectors to perform strain gauge attachment operations at beam bottoms. Next, please follow me to the detection platform for strain gauge attachment. The maximum stress section of a simply supported T-beam is the mid-span section. The position where I stand now is the test control section of the second span. This bridge consists of 4 T-beams laterally. According to specification requirements, strain gauges need to be installed on both the bottom and ribs of 4 tons beams. Below, I will demonstrate strain gauge attachment using the beam bottom as an example. What I hold now is a resistance strain gauge. The principle is that after the strain gauge is attached to the beam bottom, when the beam bottom deforms under test load, the strain gauge also deforms with the beam bottom, thereby causing changes in the strain gauge's resistance. At this point, the strain gauge can collect strain values by connecting to a static strain meter. Resistance strain gauges vary in length. There are currently 2 strain gauges here. Shorter strain gauges are suitable for steel structures with uniform material properties. Longer strain gauges are suitable for non-uniform concrete materials. T-beams are concrete components. Therefore, strain gauges with greater length are used. Before attaching the strain gauge, first check if the strain gauge wires are desoldered. After completing the inspection, then proceed to determine strain gauge positions along the bridge direction at mid-span location. The transverse bridge direction is the central axis of the beam bottom. Next is grinding the concrete surface. To ensure firm attachment of strain gauges, note that the grinding angle should be 45 degrees to the beam axis. After grinding is completed, use alcohol and cotton to wipe the concrete surface until no dirt is found on the cotton. After the alcohol on the concrete surface dries, then proceed with strain gauge attachment. Identify the strain gauge's bonding surface before installation. The strain gauge has wire solder joints on one side. The other side has no wire solder joints. The side without wire solder points is the bonding surface. After determining the attachment surface, a small amount of 502 adhesive can be dripped on the strain gauge attachment surface. Adhesive should not be excessive or insufficient. Next, the strain gauge can be affixed to the marked position and press the strain gauge for about 1 minute. After strain gauge installation is completed, we inspect the strain gauge. The inspection steps are: first, observe whether the strain gauge attachment angle is parallel to the axis. Second, whether the strain gauge attachment surface is reversed. Third, whether the strain gauge is firmly attached. The above are the steps for strain gauge attachment. Strain gauges are key sensors for strain data acquisition in static load tests. Only when attached correctly, only then can scientific test data be collected, thereby ensuring safeguarding for bridge operations.